All right, we're going to go over part 1 of 3.7. So today we're going to use the Pythagorean theorem to find the distance between two coordinate points. And so that's part 1. And so we'll do the notes and you'll do the homework. And then tomorrow we're going to do part 2, which is actually using more of a formula to find distance. So let's go ahead and start with example 1. We'll find the distance between the 2 points, -6, 2 and 1, 2. So the first thing you need to do is graph this. So go ahead and graph -6, 2. So you're going to go back 6 and up 2. And then 1, 2, you're going to go over 1 and up 2. Notice that these create a horizontal line. So we can just count across that horizontal line and see what the distance is between those 2 points. All right, so that's the second thing we're doing, is counting the spaces between the points to find the distance between them. Going ahead and doing that, we're going to count 1, 2, 3, 4, 5, 6, 7. So our distance here is 7 units. Because we're talking about distance, we always want to have a label on it. And we're on a graph, so we don't have inches or feet or yards or anything like that. So it's just going to be units, but that label still needs to be on it. Let's do another one. Let's find the distance between the points 1, 2 and 1, -5. So for 1, 2, we're going to go over 1, up 2. And 1, -5, we're going over 1, down 5. Graphing those two. And now, because we have a vertical line this time, we can count straight down that line to find the space between the points. So we'll go 1, 2, 3, 4, 5, 6, and 7. So this distance is also 7. It's not always going to be the case that it's 7. It just happens to be for these first 2 examples. So the distance is 7 units. Let's do another one. Let's find the distance between the points -6, 2 and 1, -5. So we're going to go back 6 and up 2 and over 1 and down 5 to plot those points. And so now, can we find the distance between these two? Before we could find the distance because we had a horizontal or vertical line. So we could just move straight across the line to count how many spots we move. But here we don't have just a line to move across or move down. So the answer is actually no. Whenever you have a diagonal, even if it's just slightly diagonal, in a coordinate plane or on a graph like this, you cannot just count the distance. So what can we possibly do here to find that distance? Well, we know that we can count horizontal and vertical. And so thinking about that and thinking about what we just previously learned on the last lesson, we can create a right triangle. So our legs of this triangle are going to be horizontal and vertical lines. We can find the distances of those legs by counting. And then we can use the Pythagorean theorem to find the distance of this diagonal, find the hypotenuse of that triangle. So let's go ahead and try this out. Let's find the distance between the points -6, 2 and 1, -5. So once again, we're going to start by plotting these points. So the first thing that you should do for part 1 of this section, plot the points, and then we're going to create a right triangle by connecting these 2 points vertically and horizontally. So I have my right triangle created, and now I'm going to count the lengths of the legs, which the 2 distances are the distances from the first from the first two problems. So they're both 7. And now we can use the Pythagorean theorem to find the hypotenuse, which is the distance between the 2 points. So I have my a squared plus b squared equals c squared. I'm going to plug in 7 and 7 for my a and b. And now I'm going to calculate this. So 49 plus 49 equals c squared. So 98 equals c squared. And I'm going to square root both sides and get c equals the square root of c equals the square root of 98. And now I always want you to simplify your answer. So let's go ahead and simplify this. So thinking about what two numbers can multiply to 98, where one is a perfect square, let's look at the work that we did earlier in this problem. We had 49 plus 49. Another way to say that is 49 times 2, because we're adding 49 to itself 2 times. 49 is a perfect square, so I can say 98 is square root of 49 times the square root of 2. And then I can rewrite this as 7 times the square root of 2 units. Could I have created my triangle like this blue one here, and would I have gotten the same answer? Yes, I could have, and yes, I would have gotten the same answer, because my horizontal lines are both going to have the same distance, and my vertical lines are also both going to have the same distance. So my legs are going to be the same, so my hypotenuse will be the same. All right, let's try another one. Let's find the distance between the points 5, 6 and 0, 2. So I'm going to plot these points, and I'm going to create my right triangle, and I'm going to count the distance to find the lengths of the legs of this triangle. So I find out that they're 5 and 4. And now I can work out the Pythagorean theorem to find the length of the hypotenuse, which is the distance that we need. So I have a squared plus b squared equals c squared. Plug in 4 and 5 for my a and b. 16 plus 25 equals c squared. 16 plus 25 is 41. So 41 is equal to c squared. And I'm going to square root both sides and get c is equal to square root of 41. Let's go ahead and simplify it. Square root of 41 does not actually simplify. There's no factors of 41 that are perfect squares. So our simplified answer is square root of 41 units. Let's also estimate this answer. So let's make our number line. I have square root of 41 in the middle, and now I need to think what two perfect squares is square root of 41 between. And that would be square root of 36 and square root of 49, or 6 and 7. So I know that this answer is going to be 6 point something. And now I need to figure out my fraction so I can figure out what that decimal point is. So I'm going to take 41 minus 36 and get 5. And then I'm going to take 49 minus 36, which is 13. So this is 6 and 5/13. And then if I divide that out, I find out that this is about equal to 6.38 units. All right, do this next one on your own to make sure that you are picking up on everything correctly. So work out this problem, pause the video, work out the problem, and then continue the video and make sure that you did all your work correctly. So as you go through this, you should plot the points -4, -6, and 3, -7. Create your right triangle. Find your distances of your legs to be 1 and 7. Work out your Pythagorean theorem to get c is equal to square root of 50. And that simplifies to 5 times the square root of 2 units. And then when you estimate it, you get that is about equal to 7.07 units. So a question for you is, how can we use the simplified answer and the estimated answer to check our work? We have two different ways that we can kind of check our work here. We can use the simplified or unsimplified answer. It might actually be simpler to use the unsimplified answer and plug it into the Pythagorean theorem with your two legs. So you would have 1 squared plus 7 squared equals 50 squared, and solve that down and make sure that they're equal. If they're equal, then that means that you created a right triangle, and that's one way to check your work. If they're not equal, then that means that you must have made a mistake somewhere. You can also use your estimated answer because that would be the hypotenuse, and so you can look at that compared to your two legs of your triangle to make sure that it's the longest length, because the hypotenuse is always the longest length of a right triangle. So looking at this one, 7.07 is longer than 1 and 7. So that's another way to confirm that I probably did my work correctly. Go ahead and get going on your homework. If you have any more questions, you can always message me on Canvas asking me about it. Your homework has 4 problems that you need to find the distance on. Have it done and turned in tomorrow in class.